Here's problem 1714. A car approaches a stationary police car at 36 meters per second. The frequency of the siren relative to the police car is 500 hertz. What is the frequency heard by an observer in a moving car as he approaches the police car? Assume the velocity of sound in air is 343 meters per second. Alright, so we have a police car and stationary, so the velocity of the source is 0, but it's putting off a siren, and the frequency of this siren as observed in the police car is 500 hertz. And then we have an approaching car, and the velocity of the observer is 36 meters per second. So we should get that the observed frequency is equal to the actual frequency put out by the source, velocity of sound, plus or minus the velocity of the observer, over velocity of sound minus or plus the velocity of the source. In this case, that is going to be 500 hertz for the frequency of the source, velocity of sound is 343, plus or minus velocity of the observer, which is 36, over 343 minus or plus the velocity of the source, which actually is 0. Now in this case, it is the intent of the observer to go toward the police car, and so we're going to use the top plus sign for the observer for toward. Police car is just stationary, so it doesn't really matter. We got a 0 for that, so we could have had a minus plus for that, and we're fine with that. So now what we have is that the observed frequency is equal to the actual frequency, 500, 343 plus 36 over 343. And that is equal to 552.5 hertz. So that is the observed frequency for the observer in the car, 552.5 hertz. It should have gone up because their relative locations are getting closer.